Hey guys, this is part 2 of section 5.1, multiplying polynomials, and we left off by looking at how to multiply polynomials using both the distributive property or vertical multiplication format. And the great thing about math is because there are these patterns, we can kind of take some shortcuts. We know what's going to happen. We can predict what's going to happen with these patterns, and so shortcuts kind of keep us from having to follow all the steps all of the time. So the first shortcut that you need to know about, or the first special rule, is called the product of conjugates. And a conjugate is when you have two binomials or two numbers in this form, a plus b and a minus b, and we're multiplying those together. Well, our special rule of conjugates is that a plus b times a minus b gives us a squared minus b squared. And let's take a look at why that is. Let's replace a with 5 and b with 2. We'll not even worry about variables. We'll just use 5 and 2. Well, according to our product of conjugates, we should have a squared, which is 25, minus b squared. 2 squared is 4. 25 minus 4 gives us 21. If we were to FOIL that out, we would take our first term, so 5 times 5, 25. Our outside terms, 5 times negative 2, negative 10. And inside terms, b times a, or 5 times 2, that's a positive 10, minus, or our last term, b times negative b, 2 times negative 2, minus 4. And what you'll see is when we're dealing with conjugates, our outside and our inside terms are always the same thing, but opposites. They cancel each other out. Negative 10 and positive 10. And that will happen every time. They will always cancel each other out, which leaves us with 25 minus 4, which is what we had over here. So because we know that those outside and inside terms are always going to cancel each other out in conjugates, we just have to do the first term and the last term. So that's how we ended up with 21. And that will work whether we're using number terms or terms with variables. It will work every time. So if you notice that you're multiplying binomials that are conjugates, you don't have to FOIL. You can just take this little shortcut here. Our second special product of binomials is called the square of a sum or sum of squares. You'll hear it both ways. Square of a sum or sum of squares. And that's when you have a term that looks like this. A plus b squared. So we've got a sum, a plus b, and we are squaring it. That's where we come up with the term sum of squares. Now we could rewrite this as two binomials, a plus b times a plus b, since squaring just means we're multiplying something by itself twice. And then we could FOIL, or we could use the vertical multiplication format, or we can just realize that, hey, this is a shortcut. This is a sum of squares, or square of a sum. And we can write that as a squared plus 2ab plus b squared. Again, we could plug some numbers in here, some variables, and test that out, which we will do in class. But for now, when you see a sum being squared, you don't have to FOIL. You can just take this shortcut. Another special product of binomials is the square of a difference. So again, we've got a difference here, a minus b, and we're squaring it. We could write that out as two separate binomials, a minus b times a minus b, and use the FOIL method or the vertical multiplication method to multiply those out, or we can just take the shortcut. Whenever we're taking the square of a difference, we know that our answer will be, when simplified, a squared minus 2ab plus b squared. So these three rules, these special products, are rules that you'll need to know, memorize, be able to recognize to save yourself some time. If you don't recognize them and you write it out and you multiply it, you're still going to get at the same answer, but you increase the risk for making a computation error when you're doing this FOIL method. Also, you're just spending time that you don't need to spend when you could just take these shortcuts. So let's take a look at this example. We're going to multiply 3y plus 5 and 3y minus 5. You should recognize right away that these are conjugates. Our a term is the same and our b term is the same. The only thing that's different is the operation that's happening in each of these binomials. Let's use our shortcut here, product of conjugates, which says that a plus b times a minus b equals a squared minus b squared. So a squared is 3y squared minus our b term, which was 5 squared, we end up with 9y squared minus 25. Again, if we were to multiply that out using FOIL, we would see that our middle and our outside and our inside terms would both be 15y. One would be positive and one would be negative 15y, so they cancel each other out, which is why that shortcut works. All right, try this shortcut. Multiply 3y plus 5 squared. Pause the video, try this on your own, and come back to check your work. Using the shortcut, you should see, oh, this is a sum, and I'm squaring it. So we're going to use the shortcut for square of a sum, which says that a plus b squared, square of a sum, equals a squared, let's write this out here, a squared plus 2ab plus b squared. Sorry, my handwriting is terrible on the screen. Here is our a term, and here is our b term. So we can just plug those into that shortcut and save ourselves some time. All right, here we go. We've plugged in 3y into the a squared, 2 times a times b, and then we plugged in b, that 5, into the b squared term. Notice that we are using parentheses when we substitute, and then we are going to simplify. So 3y squared becomes 9y squared. 2 times 3y times 5 becomes 30y, and 5 squared is 25. So again, we could have written that out twice. We could have FOILed it. It increases the risk for computation errors, and it also just takes more time. So let's use the shortcut. All right, last one using the shortcut. Let's multiply 3y minus 5 squared. You should recognize that as a square of a difference. So our shortcut here will be a squared minus, let's write that out, a squared minus 2ab plus b squared. So we're going to substitute in our a and our b terms into this formula here and then simplify. Right, our a term is in red, our b term is in blue. Let's plug those in. Just like before, we're going to then simplify, and we end up with 9y squared minus 30y plus 25. Since every product of polynomials is also a polynomial, the set of polynomials is closed under multiplication. What that means is that every answer will be part of the set of polynomials. We're not going to get an answer that is not a polynomial. If that were the case, we would be an open set. But this is closed because every answer is already part of the polynomial family, if you will, the polynomial set. All right, today we did these things. We multiplied polynomials using both the FOIL method and the vertical multiplication format. Either one of those would work. And we used patterns to simplify special products of binomials. Our three patterns that we need to know are the product of conjugates, square of a sum, and the square of a difference. Make sure you know those, can recognize those, and can use those. If you guys have any questions, be sure to write those down, and I will address them next class.